Please be to school.
All right, you are now on recording. Okay. Shouldn't have said that. Okay.
Not wash.
Yesterday,
My juice.
actually, 2 days ago, we learned how to solve equations with basic 8 identities. Okay.
Yes.
Now we're going to add the double angle identities, which I wrote down for you up here.
I know all those by.
Can't do that.
We have memorized these.
I don't know.
Probably
Lost a
forgot.
long time ago.
Okay. Sine of 2a is 2 sine a cosine a. Then you have 3 different ones to choose from for cosine of 2a. You got cosine squared a minus sine squared a, or 1 minus 2 sine squared a, or 2 cosine squared a minus 1.
I totally forgot the 2 in the test yesterday.
Uh-oh.
The 2 cosine, and I thought it was those identities.
Yeah,
So you got a
it
question
is
wrong?
those.
Oh, okay, never mind.
Okay, I think you were right.
Okay.
We'll see. Okay, so here we have the cosine of 2x equals the cosine of x. So we've got to choose one of these 3.
2
Which
cosine a squared a minus 1.
Why this one?
Because it's only got a cosine in it. And that way you
And
can
that
end
has
up.
a cosine in it, so everything will be cosine. If
Yes.
we choose this one. Okay. So we're going to replace, bless you, cosine of 2x with,
2 cosine squared a minus 1.
yeah, but we'll put it, 2 cosine squared x minus 1.
Minus cosine x.
Okay, you want to go ahead and move it over?
Oh, yeah.
All right.
2
2 cosine squared x minus 1 minus cosine x. Should have put it in order.
Minus cosine
Let me
x.
put it in order first.
cosine.
Yes, minus cosine x and then minus 1.
Can you,
0. And then you
Okay,
can
back to that?
Can y'all hold on a second? Okay. Now we can do what?
factor.
Factor. That's like 3 people talking at once.
2 cosine x, cosine x. 1 and 1.
Okay, why don't you write it down? Instead of just saying it. Write it
Not
down.
today. Nope.
Not today, you love.
What was that?
Which one's plus, which one's minus?
Plus
Okay.
1 minus
Right.
1.
Okay, so that gives us a 1 cosine x minus a 2 cosine x is a negative 1 cosine x.
Wait.
Now what do we do?
Equal to
Set them equal to 0.
Bless you.
My goodness. So we'll set each one of those equal to 0 and then solve.
Subtract.
Solve for cosine x.
Cosine equals
Negative
negative
1
1 half and 1.
Oh, he showed up. Just kidding.
Yep. And cosine x equals
1.
1.
Oh,
Okay, now we got to figure out when is cosine x equal to negative 1/2? When is it negative?
And 2 and 3.
Here and here. All students take classes. Okay.
And it's 1/2 at 60 degrees.
At 60 degrees for cosine? Okay, so this is 60 and this is 60. And so what is the radius?
2 pi over 3 and 4 pi over 3.
Is everybody okay with that?
Yes.
Okay, then when is cosine of x equal to 1?
0 and 2 pi.
Yep, right here, isn't it? This is 0, 1. So that's 0 and 2 pi.
Wouldn't it be 1, 0?
Yeah.
Yeah. Yes, it would. Okay. That's
Good.
better.
Good.
All right, do we need to check for anything?
No.
We're good.
No, we don't because there's nothing in the denominators. Okay? No denominators, so we don't have to check anything. Okay, now on the next one. Are everybody okay with number 1? Okay. Sine of 2x equals 0. So sine of 2x, we only have one choice for it.
2 sin x, cosine x.
Mm-hmm. Okay, what about from there?
Pull out a sine.
You said it equal to 0.
You
Set
separate
each one equal to 0?
Yeah.
Okay. What about the 2?
You just delete that and don't worry about it.
Just get rid of
We
it.
can do it. How can we get rid of it?
Divide by two.
Divide by 2. You were right and you didn't think you
Just
were.
get rid of it.
So sin x cosine x equals 0. Now we can set each one of these equal to 0.
Sine equals 0, cosine equals 0.
So pi of 2. Yeah,
It's all the quadrangles in it. Because when sine is 0, cosine is 1, and negative 1, and when cosine is 0, sine is 1.
Is there a way to write like all the quadrantals?
Yeah, you list them.
0, 2 pi.
0 pi and 2 pi. And then pi over 2 and 3 pi over 2. Didn't have any denominators, so we don't have to check it.
I know, I always forget to throw it on.
0 and pi, because, okay, it says from 0 is less than or equal to x.
Oh,
less
because
than or
you
equal to
have to
2
put the 0 because this is 0 pi.
0 is at this point right here. This is 0 and 2 pi. Okay?
Okay.
You're right.
It's good. Good.
Now we're omitting 3 and 4.
Alright.
We're going to look at the domain restrictions though for each trig function. In other words, what can x not be? And this is going to help you a little bit when you're checking. Okay?
I
So
like it.
sine of x, is there anything sine can't be
No.
in the unit circle? Can be anything.
Can't be 2.
True. But it just said, no, it doesn't say that. It has, this is between 0 and 2 pi. Okay? So there's no restrictions. Or I guess you could say it has to be between 0 and 2 pi. Okay, but let's just do that. We know that for all of them. So now cosine of x, can it be, is there something it can't be between 0 and 2 pi? No restrictions. The only time you're going to have restrictions is when you have a denominator.
Isn't 2 in between 0 and 2 pi?
Not
You're
2.
actually like multiply pi out.
That's a radian.
Oh.
I mean, that's a, yeah. Okay. How about f of x is equal to tangent x?
Can't be
3
pi
pi over
2.
2 and pi over 2.
Why?
Because the zero's on bottom, that makes it undefined.
Because that's wild for x. And the x
Yes.
is 0.
Tangent is the same thing as sine over cosine. Okay.
And wherever cosine is 0.
Whenever cosine
then
is 0, it's going to be undefined. So x cannot equal pi over 2 and 3 pi over 2. Okay, now how about d? What is cosine x equal to?
1 over sine.
So wherever sine x is 0, it would be undefined.
So
So
0
0
pi
pi
and
2
2
pi.
Sine x is 0 at here and here. So x
0.
cannot equal 0
Pi and 2 pi.
pi and 2 pi. Okay, for secant,
1 over cosine, x can equal pi over 2.
right, so cosine can't be 0. And we said cosine at 0 is 0 at
Pi over 2.
3 pi over 2. And then cotangent,
Cosine over sine,
so sine can't be 0.
x can equal 0 pi or 2 pi.
I know if you could kind of maybe start to memorize that a little bit, it might help you. If sine is in the denominator, then 0 pi and 2 pi cannot be answers. If cosine is in the denominator, pi over 2 and 3 pi over 2 cannot be answers.
Got it.
So these are really the ones to look for. Okay, when cosine's in the denominator, when sine's in the denominator. Everybody got that all right?
Yeah.
And we're omitting the rest of it.
Yes.
No win.
Good day. And all of the assignments as well.
1 through 7.
Just gonna burn the packet.
Take it out like we did that too.
1 through 7.
1 through 7.
Yes. First one, I have to say I appreciate that you didn't do the rest of them. My second comment is why
I like to
What, why what?
Last mini.
Yeah, I cannot figure it out.
Do you have extra?
Let me see what I can find.
On budget.
Yeah.
1 through 7. I put that somewhere. I'm gonna see if I can find it.
No, that's fine.